Okay, so now that we've established that the three angles of a triangle add up to 180 degrees, let's use that fact to help us solve some problems and get a handle of how we can use this um, when dealing with triangles. So this problem says one angle in a triangle is twice another angle, and the third angle is 54 degrees. What is the measure of the smallest angle in the triangle? Okay, so you have three angles in a triangle. One of them is 54 degrees. One is twice the amount of the other. So, all right, if we say, well, obviously, if something's twice as big, then that's going to be the larger of the two. So let's call that smaller angle just x. And then the one that's twice the amount of the other angle would just be 2x, 2 times x. And then we have the three ways to write out the three angles of our triangle. So angle number 1, you can just call x. Then the angle that's twice as much is 2x. And the third angle is 54 degrees. Now, we know from the last proof that we did that the three angles, when added together, equal 180 degrees. So we can use this to basically solve our problem, and it's just a relatively straightforward algebra problem. Combined like terms, x plus 2x is 3x. We have our 54 degree angle left over, and that's equal to 180. So subtract 54 on both sides of the equation to help get x by itself. We have 3x is equal to 180 minus 54. That gives us 126. Now we have 3x equals 126. To get x by itself, we're going to divide by 3. And this leaves us with the fact that x is equal to 42 degrees. Okay, so we know the three angles of our triangle are 42 degrees. We have the 54 degree angle, and the one that's twice as much as the 42 degree angle, so 2 times 42 is 84. Meaning that the smallest one is 42 degrees. So this 42 degree angle is the smallest angle of the triangle. Okay. All right, let's try out another one. This one's a little bit more involved. So this one combines basically everything we have worked on so far: parallel lines, angles of a triangle, writing equations, etc., etc. So let's have a look at it. In the diagram, M is parallel to N. The segment AB is perpendicular to the line M. Angle ADC is equal to angle BCE, which is equal to 3x. Angle CEB is equal to 50 degrees. And angle BCD is equal to x. Find out what the value of x is. Okay, lots of places to start here. Let's start with the fact we have two parallel lines, M and N. So parallel lines usually means find the angle relationships that you can work with. And again, in parallel lines, the angles are either equal to each other or they're supplementary to each other. So let's take a look. We have one angle, this 90 degree angle formed by the line M. And that's, again, M is parallel to N. I use the little arrows to indicate that. This 90 degree angle must be alternate interior with this angle over at ABE. This one right here. Alternate interior. Again, look at the interior of the parallel lines. It's this region. Alternating sides of the transversal. And alternate interior angles are equal. So now we can deduce that angle A, B, E is equal to 90 degrees. Okay. So, where can we go from here? Well, we want to find x. We know some certain rules, like the three angles of a triangle add up to 180 degrees. So, one thing you might note is that, okay, we have a triangle AEB. The three angles would be angle EAB, this one right here, angle AEB, the 50-degree angle, and angle ABE, the 90-degree angle. So we know that those three must add up to 180 degrees. Angle EAB plus angle ABE plus angle AEB is equal to 180 degrees. Okay. Well, what can I do here? Well, let's substitute whatever we know. So, for example, angle EAB. We don't really know much about, so I'm just going to leave that the same. Angle EAB, we don't know much about, but I do know angle ABE is 90 degrees. And angle AEB is 50 degrees. And that's equal to 180 degrees. Okay, so if we just combine like terms, start simplifying, we can figure out what angle EAB is equal to. So angle EAB plus, well, 90 and 50 is 140. That's equal to 180. Subtract 140 on both sides. And we find out that angle EAB is equal to 40 degrees. Okay, that's something. This is a 40-degree angle. How does that help me out? Well, again, three angles of a triangle add up to 180 degrees. So, we have just found the third angle of the triangle AEB, but that angle isn't just belonging to that triangle alone. Look at triangle ADC. We have now discovered that that triangle has a 40-degree angle in it because of the angle CAD, and it has this 3x angle right over there. So with that, we can find out what the angle ACD is. Because again, the three angles of a triangle must add up to 180 degrees. So again, look at triangle ACD, add up those three angles, set it equal to 180. So that's angle ACD plus this 40-degree angle plus 3x is equal to 180 degrees. Well, I'm running a bit out of room here, so I'm just gonna do the algebra kind of like, in one go. If we subtract the 40 and subtract the 3x, what we would have left over is that angle ACD is equal to 140 degrees minus 3x. So, why is that important? Well, we don't know exactly what angle ACD is, but again, I know it's 140 minus 3x. So if we look at the angles sort of next to it, we have x and 3x, and those are all one variable. And if we have an equation in terms of one variable, we can start solving for that variable. But how could I create an equation using those three angles? Well, look at them, look at their geometry. If I take all three of the angles, throw them together, they form a straight angle, 180 degrees. The three angles are on a straight line. Put them together, it must equal 180 degrees. Don't forget the old facts that we went over when tackling these newer problems out. So, let's go ahead, and I'm probably going to have to just start on the next page. Let's see. Yeah. So, okay. Again, I'm going to take these three angles, 140 minus 3x, x, and 3x, set them equal to 180. So, 140 minus 3x plus x plus 3x is equal to 180 degrees. Again, just took the three angles, set them equal to 180 because they're a straight angle. Combine your like terms, we have negative 3x, positive 3x, that's going to cancel out. So what we have left over is 140 plus x is equal to 180 degrees. Subtract 140 on both sides. And we have that x is equal to 40 degrees. And that is it. X is 40 degrees. That's what it was equal to all along. So, again, when we're approaching these problems, use all the information you can. Don't forget the things we've learned about. That a straight angle is 180 degrees. That alternate interior angles are equal. That the three angles of a triangle add up to 180 as well. All the facts we've learned about in the course so far have been used in this problem in some way. So it's just a good demonstration of why it's important to keep in mind sort of all the tricks up your sleeve when tackling any problem. So that is it for this lesson. Next lesson is on the exterior angles of triangles, so stay tuned for that.